Morning. I just wanted to run through some points maybe, or some terms I suppose, that you might have come across when you were looking at the sample solution 2007 question 5 that I put up yesterday. So can you just have a quick look at this diagram firstly, and we'll just run through maybe the difference between main energy level, sub-level and orbital, okay? So like you can see here, look on the left, that you've got the main energy levels here, 1, 2, 3 and 4, okay? So they're your main energy levels. Now you can subdivide those main energy levels into sub-levels. So can you see here, like the first main energy level just has the 1 sub-level, but look, the second main energy level has 2, the third main energy level has 3, and the fourth has 4, and so on. Now what's a sub-level? So a sub-level is a subdivision of a main energy level, look, okay, consisting of one or maybe more orbitals of equal energy. So like if you just have a quick look for a minute now at your 2s sub-level here, okay? Your 2s sub-level consists of just one orbital. That's why you've got a straight line here, all right? The 2p sub-level consists of 3 orbitals. Look, 3 orbitals. Now what would they be called? Well, they'd be called px, oh, my writing isn't great on this, py and pz. Do you remember that? So there's 3 broken lines there, or the 2p sub-level is broken into 3, I should say, because the 2p sub-level is made up of 3 orbitals, px, py and pz, okay? And you can see it there again, look, with the 3p sub-level is also made up of 3 orbitals, all right? Now, each orbital holds 2 electrons, all right? So if you look here, for instance, where he has the 3p here in the box here, look, he has that the 3p sub-level holds 6 electrons, because you can put 2 electrons into each orbital. So 2, 2 and 2 makes the 6. If you look at the d sub-level, the d sub-level is subdivided or broken up into 5 different orbitals. Each orbital could hold 2 electrons, so you can put 10 electrons into the 3d sub-level then, okay? So just please don't mix up. These are your main energy levels here. The main energy levels are subdivided into sub-levels, and then the sub-levels consist of different numbers of orbitals. So the s sub-levels, just the 1 orbital, okay? The p sub-levels, 3 orbitals, and the d sub-level actually has 5 orbitals, and you don't need to know the names of the d orbitals, so don't worry about that, okay? Now, Hund's rule of maximum multiplicity, all right? Sorry, now I just want to go out of that for a second and just talk to you about this. Hund's rule of maximum multiplicity states that when 2 or more orbitals of equal energy are available, then the electrons will occupy them singly and then come back and fill them in pairs. So for instance, if you look at boron, here, you just let me mark this up now, just 2 seconds. So if you look at boron here, you can see that boron has 5 electrons, okay? So you have 2 in the 1s, 2 in the 2s, and 1 there. But you see underneath, you're going down to carbon, then down to carbon here, you can see that it's got 1 in the 2px, 1 in the 2py, and then going down to nitrogen, you've 1, 1 and 1. And then what you have to do when you're introducing another electron to the oxygen, you go back to the 2px. So you fill them singly first, and then you come back and you put the electrons in pairs. They're called arrow and box diagrams. Sometimes you might be asked to draw them. The box represents the orbital and the arrow represents the electron. So you always only have 2 electrons per orbital, okay? So that's that done. Now, just quickly, I just want to have a quick look now. So at the solution that I gave you yesterday about writing electron configurations and that, all right? So you can see there that it asked you to write the electron configuration for sulfur, which we've written there, and it shows how the electrons are arranged in the higher occupied orbital, which was your 3px, your 3pys, and your 3pzs. So I had to put 1 into each orbital first, and then I came back and I filled the 3px again with 2. Now, it asked you there it asked you there to Okay, so it asked you there to identify the number of energy sub-levels that were occupied, all right? So energy, main energy levels here, all right? So you can see that here. So you have one, you have the second main energy level, and the third main energy level was occupied. So that's 3 energy levels, okay? Then it asks you to identify the number of orbitals, okay, that was occupied. So the 1s, okay, just consists of 1 orbital. So that's 1 orbital there. The 2s is 1 orbital, okay, so plus and plus. But the 2p is actually 3 orbitals, 2px, 2py, and 2pz, okay, so that's 3. 3s is 1, and then you have 3 orbitals here again for the 3p sub-level, okay? So when you add those up there, you get 1 and 1, 5, 1, 6, and 3 is 9. So 9 orbitals occupied. Now, just finally, can we just, if they had asked you how many sub-levels were occupied by sulfur, well, what would the answer to that be? How many sub-levels? All right, so the first main energy level is just 1, so that's 1. 2s is just 1, so that's another sub-level. Then you have 2p is a sub-level, 3s is another sub-level, and 3p is a sub-level. So you'd have had 1, 2, 3, 4, 5 sub-levels would have been your answer if they had asked you that. Okay, I hope that helps. All right.